Our universe is a vast and mysterious place. We long to know its secrets. One of the biggest questions we ask is, how did it all begin? The most accepted theory is the Big Bang. Imagine a tiny point packed incredibly densely with energy. About 13.8 billion years ago, this point exploded. This wasn't an explosion like dynamite, sending debris outwards. Instead, it was space itself expanding. Imagine a balloon with dots drawn on it. As you blow air in, the dots move apart. The universe is like that balloon, always expanding. This expansion continues even today. Astronomers observe galaxies moving away from us. The farther the galaxy, the faster it recedes. This observation supports the Big Bang theory. In the first moments after the Big Bang, the universe was incredibly hot. It was a sea of pure energy. As the universe cooled, this energy began to transform. Subatomic particles like quarks and electrons formed. These particles are the building blocks of everything we see around us. After the initial fiery chaos, the universe began to take shape. Gravity, a fundamental force, started to exert its influence. Clouds of hydrogen and helium gas, the simplest elements formed after the Big Bang, began to clump together. These clumps grew denser and hotter under gravity's pull. Eventually, the temperature and pressure within these clumps reached a critical point. Nuclear fusion ignited, flooding the surrounding space with light and heat. Stars were born. These first stars were massive and short-lived, ending their lives in spectacular supernova explosions. Stars didn't form in isolation. Gravity continued to draw them together into colossal collections. Galaxies emerged, vast islands of stars, gas, dust, and mysterious entities like black holes and dark matter. Our own galaxy, the Milky Way, is just one of billions of galaxies scattered throughout the observable universe. The quest to understand the universe is not confined to modern science. Centuries ago, Islamic scholars made significant contributions to astronomy and cosmology. They saw no contradiction between faith and the pursuit of knowledge. In fact, the Quran, the holy book of Islam, encourages observation and reflection upon the natural world. The Quran speaks of the universe's creation in a way that aligns remarkably well with modern scientific understanding. For example, the Quran states, "Have those who disbelieve not considered that the heavens and the earth were a joined entity, and we separated them?" 21:30. This verse echoes the Big Bang's concept of the universe originating from a single point and then expanding outwards. Muslim scholars like Ibn al-Haytham, known for his groundbreaking work in optics, challenged existing theories and emphasized empirical observation. Their contributions paved the way for later scientific advancements. Islamic cosmology reminds us that the pursuit of knowledge is a universal endeavor, transcending cultural and historical boundaries. The universe, as we know it, had a beginning, but how will it end? This question has captivated cosmologists for decades. Two leading theories propose contrasting fates: the Big Crunch and eternal expansion. The Big Crunch suggests that gravity might eventually halt the universe's expansion. Like a ball thrown upwards that falls back down, the universe would contract, collapsing in on itself in a fiery, dense singularity. The other possibility, eternal expansion, paints a different picture. Driven by a mysterious force called dark energy, the universe would continue expanding indefinitely. Galaxies would drift farther apart, becoming increasingly isolated islands in the vast cosmic ocean. Stars would eventually die out, leaving the universe a cold, dark, and empty place. The universe's ultimate fate remains shrouded in mystery. Will it end with a bang or a whimper, or perhaps a scenario we haven't even imagined? The answers lie hidden in the fabric of space-time itself, waiting to be unraveled by future generations of curious minds.